Maths is everywhere. Today we're going to be doing a lesson about maths in nature. One way of keeping maths interesting and real to children is to demonstrate that maths is observable and measurable in life and natural phenomena. Mathematical concepts such as patterns, geometry and symmetry are all evident throughout nature. Today we're going to be doing the Fibonacci sequence. The Fibonacci sequence was developed by an Italian mathematician, Leonardo da Pisa. This is it. Basically, every number is the sum of the previous numbers. So 1 and 1 is 2, 2 and 1 equals 3, which I've also shown here as well. Okay, 1 and 1, 1 plus 1 equals 2, 2 plus 3 equals 5, and the sequence carries on. Okay, now to get on to the activity itself. This activity is intended for grade 5 and 6, usually 10, 11, 12-year-olds, but can be adapted for a younger or older class. So, first part of the activity, as a big group, I'm going to hand around objects such as these, which are flowers. Also got a pine cone, and I've got snail shells, etc. I'm not going to tell the kids what the activity is actually about, but let them know that this is a clue. They're going to work it out themselves. So, putting them into groups of 4 or 5, I'll give them a calculator and 3 envelopes. In each envelope is a different activity. Awaiting my instructions, they open envelope 1. In envelope 1, they will find numbers. Now, you may wish to not use the actual numerals and put 5 objects on a piece of paper or 89 objects. I'm just using this for today. You also might want to use more colour. Now they should, going around the classroom, I'll be prompting them to making sure they're seeing a pattern in the numbers, and maybe ask questions like, or encourage them to put them in order of size, so they can maybe see the pattern and collaborate amongst themselves. So eventually the pattern should look something like this, which is the Fibonacci sequence. I'll ask them if they know what this sequence is, if they've ever heard of it, or if they know the name of it. And then carry on to activity 2. In envelope 2, they'll open that as a little group and find rectangles with numbers on them. This activity requires them to empty the squares out and make a big rectangle with these squares in order of number. So this should end up looking something like this. So as you see, 1, 1, 2, and these are all following the Fibonacci sequence. Then, moving on to activity 3, I'll ask them to open up the next envelope, which does have this rectangle in it, and ask them to put a dot in each corner, going from this way to that way in each square, and then join the dots up, which should lead them to create something that looks like this, which is a Fibonacci spiral. After the activities, I'll get them to come back as a group and explain that the sequence they've been using is called the Fibonacci sequence. We'll put the numbers back up on the board, and then I'll hand out the pictures again. I'll ask them if they can see the relevance in the pictures. So, for example, this flower, you count the petals, you'll find that it's a Fibonacci number. These snail shells also can Fibonacci spirals, and I'll show them this photo to demonstrate. Pine cones, all the seeds have a Fibonacci number, etc. and so on. Reinforcing the idea for the lesson and letting them know what the lesson was actually about. You might want to extend this further and take them outdoors and let them explore nature themselves and see if they can find Fibonacci numbers or spirals or patterns in the garden. Again, this activity is intended to help them see maths in the real world. So when they are out on their own, that they'll know that maths isn't just for the classroom or isn't just numerals. It's about everything and every part of what they do.